Hello, sixth grade, and welcome to your introductory lesson on ratio tables. Now, to start off our lesson today, we're going to look at this problem. It says 1 can of frozen orange juice concentrate is mixed with 3 cans of water to make 1 batch of orange juice. And I have that shown here. Here's my 1 can of juice, and then here's 3 cans of water. That's how we make OJ. So now it says how many cans of juice and how many cans of water would you need to make 2 batches that have the same taste? 3 batches. Draw a picture to support your answer. Well, to start this one off, we could draw a picture as it says. Here's for 1 batch, right up here. Now, to make 2 batches, I double it, right? So, I'd have 2 cans of juice. And 1, 2, well, 3 makes just 1 batch of orange juice. I want to make 2 batches, so again, you double that as well. And I'd have, for this one, 2 juices and 6 waters to make 2 batches. And again, you do it one more time. If I drew a picture for 3 batches, that means everything is times by 3. So 1 juice turns into 3 of them. So it takes 3 cans of orange juice. And then, well, here's for 1 batch. Here's for 2 batches. And here is for 3 batches. So to make 3 batches, I need 3 cans of juice and 3, 6, 9 cans of water. Now you're asking, what does this have to do with anything maybe? Well, these are ratios. When I do 1 to 3, 2 to 6, or 3 to 9, all of these are equivalent ratios because I could divide this out. For 2 to 6, they both can get divided by 2, and I end up with 1 to 3. Same here for the 3 to 9, I could divide by 3 and still end up with it. So ratio tables name the equivalent amounts. Plus, they help organize. So when I drew out those pictures, yeah, I could actually see them, but it was a little messy because of all the pictures. So a ratio table tells the same information, but in less space. It's organized. And you'll see right here, for 1 batch, here's my 1 can of concentrate to 3 cans of water. Here's my 2 to 6, and here's my 3 to 9. So all those come together, and that same information is shared, but in table form. That's what we're looking at, creating tables today, and also organizing and finding missing information. So here we go. To make yellow icing, 6 drops of yellow food coloring are added to 1 cup of white icing. Use the ratio table to find out how much yellow to add to 5 cups of white icing to get the shade. So my question is, how would you solve this? Well, one thing you could do is, again, extend the pattern or make a table. So here, I made a table and I have the cups of icing and the drops of yellow. And it says right up here, for every 6 drops of food coloring, you get 1 cup of white icing. So I have that here. For icing, there's 1. For drops of yellow food coloring, there's 6. Now what I can do is just extend the pattern or keep doubling until I get to that 5. So for 2 cups, I need, well, here I times by 2, so, or double, 1 plus 1. 6 plus 6 is 12. I do the same here. For 3, well, I need 6 groups of yellow drops, 6, 12, 18. 4, 6 plus 6 plus 6 plus 6, or 6 times 4 is 24. And if I finish it out, 5, so if I had 24, another one here would make 30. So I need 30 drops. Now, that might be one way to do it. Maybe you just extend the pattern. I know some of you might have just noticed too, well, I could just make a shorter table. If I know it's 1 to 6, well, if I times by 5, 1 times 5 is 5, 6 times 5 is 30. So you get 30 again. So 30 drops of yellow icing. Okay, and again, these are in your notes, so you are hopefully taking notes as we do these, as we go along. So here's this one. A patient receives 1 liter of IV fluids every 8 hours. At this rate, use a ratio table to find out how many hours it would take to receive 4 liters of IV fluids. And again, this one I actually shortened up. I just did 1:8 as 4 something, but I could do 1, 2, 3, then 4 and double it that way. But me, myself, I like to look at the multiplication aspect. What can I do to go from 1 to 4? Well, I would do 1 times 4. So I do it here. Now, some of you might think, well, I could just add 3 as well, but if you extended the pattern, 1 fluid is in 8 hours, 2 fluids is in 16, 3 fluid is in 24, 16 plus 8 is 24, 4 is 32, and 8 times 4 is also 32. So it would be 32 hours. Okay? So here we go. Final two, or here's one I want to do quick. Cans of corn are on sale at 10 for $4. Use a ratio table to find the cost of 15 cans. So if we were to solve this, this one isn't so easy because I can't just do 10 times something is 15. I can't times 10 by anything to get 15. But what I can do is use multiples. So if I look, 10 and 15 are both multiples of one number. Yes, they're multiples of one, or, well, you wouldn't really consider it multiples of one, but they are both multiples of 5. So if I look, I know I can go from 10 to 5, and then I can go from 5 to 15. So to do this, to go from 10 to 5, I divided by 2, so I do the same here. 4 divided by 2 is $2. So now I can get 5 cans of corn for $2, and then I continue it. 5 to what gives me 15? Well, 5 times 3 is 15. So I do the same down here. 2 times 3 is $6. That's my answer. So we have these two now, if we continue it out. Okay, so we're going to try 1 and 2. On a piece of paper, I want you to do these two and then hand it in to your sub today. Have a great day. Hopefully you're being awesome because I know you're all awesome 6th graders. Adios.